Saxon Math Course 2. We are on Lesson 30, making big progress this year in this textbook. And Lesson 30 is a milestone because there are 120 lessons total, and getting to 30 of them, we have taken quite a chunk of a book, and a fourth of the book is completed. So that's a big deal today, and so we can celebrate that. So we are going to be looking at something called common denominators. What is a common denominator? If I have a fraction of 1/2 and I want to add 3/6, I have a problem. And the problem is this: this 2 and this 6 have to be the same denominator. I have to make them the same. Up top, I can add those, but because we're not talking same on the bottom, we still have some work to do. All right. So what I usually do is take the larger fraction, 3/6. Okay. So 1/2 and 3/6, and I add them like this. And so what I do is I have to make equivalent. So because this 6 right here and this 3 right here um, are the larger fraction, I'm going to leave those alone. And what I'm going to do is I'm going to put 6 here, and I have to ask myself, what number times 2 equals 6? What is this number right here? Well, it's 3. Whatever that number is, I multiply by the numerator. Oh, look at that. 3/6, it's the same thing, and you know that. 3/6 is the same as 1/2. So 3/6 plus 3/6 equals 6/6, or 1. Okay, so this is all about finding common denominators. Now, we can find them looking for the least common multiple, right? So let's do this. What about 1/4 and 1/3? Let's add those two fractions, okay? All right, what are the multiples of 4? Well, we have 4, 8, 12, 16, 20. What are the multiples of 3? Well, it's 3, 6, 9, 12, 15, 18, 21. Let's stop there. All right, what's the common one here? Oh, there it is, 12 and 12. So I know for these fractions, they will both have to be changed to a denominator of 12. Well, what times 3 equals 12? It's 4. So I say 4 times 1, and that's my new fraction. Okay? Same thing here. 12 on the denominator, so this is going to be 3. So 1 times 3 equals 3. Now I can add them. 4 plus 3 is 7, and I keep the denominator the same, 7/12. All right? So it's relatively a simple process here. Let's look at example 2. Here we have a fraction, and it's 5/6, and then we're going to compare that with 7/9. Okay, so we have to figure out what is the common denominator. Okay, well, if we did multiples of 6, it would be 6, 12, 18. We'll stop there. Multiples of 9, 9, 18. Oh, there it is. Okay, so if the common denominators are 18, let's rewrite them with 18. Okay, well, what times 6 equals 18? Well, we know that that's 3. So 3 times 5 is 15. Okay, we know that 2 times 9 equals 18. So 2 times 7 is 14. Now we're talking apples to apples, because the denominators are the same. Now all we have to do is look at the numerators and say which one is greater. So 15 is greater than 14/18, right? So our answer, literally in the circle, is the greater than symbol. And yes, that is correct. Yay! Happy face. Well, give him some hair and a goatee and a couple of ears. All right. Anyway, that's the kind of work that you're going to be doing in this chapter. Let's look at example 6. Because or 5 rather, it's just a subtraction problem. Same principle. Okay, we have 5 over 6 minus 3 over 4. Okay, we have to find a common denominator. 6, 12. We don't have to go any further than that because I know that 4, 8, then 12. There's my commonality. All right, so we need to change these to common denominators of 12. 6 times 2 equals 12, so that means we're going to multiply 5 by 2 and get 10. 12 on the denominator here, we know that that's 3, so 3 times 3 equals 9. 10 minus 9 is 1, and we keep the denominator. There we go. There's our answer, 1/12. All right, you have similar problems all the way through. Sometimes you're going to get multiples of fractions. Sometimes you're going to get multiple fractions, adding and subtracting. It's all about finding common denominators and then doing things in order. So if you have any questions, talk to me. Pretty easy lesson, but it may take a little work to get this skill down, but relatively easy and a necessary one for the rest of your algebraic careers. All right, have a good lesson.